So today, in the beginning part of the lesson, I'm going to show you how to find the zeros for functions that are more complicated. One with a radical, square root, and then one that's a fraction. This is called a rational function. Okay, so I'm gonna graph the top one first, then I'm gonna put the bottom one, and I'm gonna show you what the graphs look like as is. And you're gonna see that when I put them in to the calculator, the way they look now, the graphs are gonna be really funky. So I'm gonna have to do some fiddling around in order to find the zeros. All right, so I brought up the calculator. I'm gonna put the first function in now. How do you do a square root? Well, here's square, and square root is the opposite. So you hit second, and you go down to where the square root thing is, and it gives you a nice little radical. Depending on the version of the calculator you have, it might just put, SQRT for square root. So I'm gonna put x squared in there. And then I had negative x, take away x, take away 4. And I'm gonna hit enter. Now I'm gonna graph this bad boy. Notice my window is 10 by 10. I didn't mess with my window. I left the window 10 by 10. So now, whoa, shit. You get like these weird ass antennas. And then you're like, what? What's it like error, error, error. Notice this thing, the zeros are where the graph touches the x-axis. This graph doesn't even touch the x-axis. It kind of looks like negative 1.9 or something, or, like this is like maybe 2.9, but it doesn't touch. So you trying to hit second calculate 0 is going to fail miserably. So this doesn't work. So the secret, the trick that you do, you're looking for where the function is equal to 0. But if you have a square root and you want to know where it's 0, then you just have to take the inside part and set the inside part equal to 0. So when you see the square root and you're looking for zeros, you ignore the square root. You just graph this dude, the inside dude. You graph x squared, take away x, take away 4, who is the guy inside the radical, and you graph him. You're gonna see it's gonna be a nice cube parabola that crosses twice. And now I'm gonna find his zero. So I'm gonna second calculate. I'm gonna hit 2 for 0. Now remember, some of you have trouble with this. Left bound. Start moving the flashy thingy to the left. There. I have a look at the y. It says 1.5. It's positive. Hit enter now. That's my left bound. Now I need a right bound. Now start doing it until you cross the x-axis. Boom. Look at my number. Negative 1.09. Now I can hit enter twice, and it'll tell me the first 0. So I get negative 1.56. I'm going to write it on the board just so it's there when I show that again. So you couldn't see that part. Now I'm going to do the second 0. Second, calculate, and hit 0. Now again, left bound. This time, the left bound is going to be underneath. It's got to be left, right? These are the numbers to the left. So again, look, negative 2, negative 1.6. I'm going to hit it now. I'm going to hit enter. I want to go as close as I can. I have to cross the x-axis to get to positive number range. There we go, positive 1.89. Enter, enter. You should be trying to do this with me. So you get 2.56 as the other 0. So 2.56, interesting. There's a little symmetry there. I had negative 1.56 and I have 2.56. Okay, so those are the zeros, and that was the trick to figuring them out. You can't draw the square root thing. You saw how weird and effed up the graph looked when you tried to do that. So that's going to fail. If you try to find the zeros with the radical, it's not happening. All right, so you got to use the trick. Now, the second one was a fraction. Okay, so you had x squared minus 3x minus 4 on top. Now, I want to show you something that, like in web work, you guys should already know. If you're trying to enter a fraction in web work, like let's say I want to just put x plus 3 over x minus 2, like in web work as an answer, and I do this. I go x plus 3 divided by x minus 2. The thing is going to think that if you put preview answer, this is what it would give you. The web work would see it does the order of operations. It'll do 3 divided by x, and it'll keep this there, and it'll keep this there. So when you put these in the graphing calculator, you have to make sure that you put parentheses around everybody on the top and parentheses around everyone on the bottom. If you don't do that, the calculator is going to misinterpret what you're trying to enter, and you're not going to get the graph that you're supposed to. So like I just showed you, I'm going to put parentheses. I'm about to enter a fraction. So everybody on the top gets parentheses. So I have x squared. Again, try to do it with me. Minus 3x. The good thing is you'll be hopefully watching this later. Again, like I said, it's a great way to fall asleep. If you're having trouble sleeping, just turn this shit on and just listen to it, and you'll drift right off. On the bottom, I had x third minus 1. So you put x, the little hat thing, to the third, come out of the power now, and then put minus 1. And then close the parentheses, and then hit enter. And make sure it's what you want. X squared minus 3x minus 4 on top with parentheses, and then divided by parentheses x third minus 1. All right, so now I'm going to hit graph. Keep fingers crossed. Oh boy. What? Okay. I mean, I can see that it crosses once over here. Oh, that looks terrible. Whatever. So I could, this is the huge disadvantage to not doing this on the iPad. So, but I can see that it crossed once. I don't know what the fuck is going on over here. I mean, this isn't happening. So again, I need a way to adjust this so that I can make a picture that I can figure out where it crosses. I mean, look at this graph. This graph is fucking ridiculous. I mean, what can you do with this? I mean, yeah, I could kind of figure out that one, but I can't do more than that. So when you have a fraction, like let's say I had x minus 1 over x plus 2, and I wanted to know where this is equal to 0, right? This is how you would find the x-intercepts. This is how you find the zeros of the function. A 0 means that the function is equal to 0. So the only way that this is going to be equal to 0, remember, the bottom can't be 0, right? This is undefined. I call it BS. So you can't do this. So the only way you can figure out where the fraction is 0 is to take the top dude and set him equal to 0 and solve it. And now if you were to plug 1 into that, on the top you get 1 minus 1. On the bottom you get 1 plus 2. So what do you get? You get 0 over 3. 0 over 3 is 0. Yay, perfect. This is how you figure out where the fraction is 0. You set the top equal to 0. The bottom cannot be 0, right? Remember domain, the freaks, the big D. You can't have x being equal to, right? X can't be equal to -2. If you put -2 in here, you get a 0 on the bottom. Bad. So the bottom is never going to be 0. So if I want to know where the fraction is 0, I care about the top. I ignore the bottom completely. So what this means is if I'm trying to find the zeros of the fraction, I don't put the fraction into the calculator. As soon as I did that, I completely screwed myself. You saw how effed up that graph looked. So I'm going to take the top, which is x squared minus 3x minus 4. Shit. Perfect easy. You teacher screws up. X squared. Just fix that easier. Minus 3x minus 4. Trying to be careful. So I'm going to graph only the top of the fraction. And again, I have a nice easy as parabola to graph. And you know, if we want to cheat a little, I see one of them right here in my table. If you look at the table, this time I'm going to use the pen. If you look over here in the table, you see that when x is 4, y is 0. So yay, I got one for free. I didn't even have to do anything. I'm gonna compute one of them. So I can see on my table that one of them is 4. And look over there on the graph, you can see that it crosses at 4. So I'm gonna hit second, calculate. I'm gonna do the 0 on the left. So again, left bound. I need to make sure flashy thingy moves. Whoop, that's too far, but it's fine. So put the flashy thingy above the x-axis and enter. Now move the flashy thingy below the x-axis. Make sure the numbers switch from positive to negative. And then the calculator can look where it turned out to be 0. So -1. So, and again, you could have looked for these on the table. They're nice. So I get -1 And again, looking at the picture itself, you can see that the other one is 4 right there. All right, so again, I could calculate it, the other one, but I already know it's 4 from the table. I can see on the table that it's 4, 0. And, I also can see visually, I can count the little tick marks there, 1, 2, 3, 4. I can see that it crosses again at 4. So my zeros for that one are -1 and 4. Now I have to check something. So the zeros that I got for this were x equal -1 and x equal 4. Now there's one thing you have to be super careful about. Remember, all I did was graph the top, and I found the zeros of the top. However, I ignored the bottom. But the thing is, the function is made up of a top and a bottom. So you can't just completely disregard the bottom and say, screw the bottom, I don't give a damn. You have to make sure that the two numbers you got do not make the bottom 0. Because if they do, remember what I said when I taught you the big D, they're freaks. If you plug this number into the bottom and make a 0, you have to toss this number out. So you have to check this really quick before you finish this question. It's obvious that 4 to the third take away 1 is not 0. So he's cool. This is one of my zeros. Now, -1 to the third, if this was +1, like if this had been x to the 4th, this guy would be thrown away. If this was x to the 4th, -1 to the 4th would be +1, and 1 minus 1 would be 0 on the bottom. I would throw this guy away. But -1 to the third is -1, and -1 minus 1 is not 0. It's -2, right? So this dude is okay also. So they both work. But the point is, if you don't check this, check this part, you could get a freak. And you're like, oh, what are the zeros? It's -1, but it's not. And he was really a freak in disguise, hiding. So you had to throw him away. Okay, so a lot of subtlety here. So this is the lesson notes where I explain to you, if you have a square root, you graph the inside, find the roots. If there's a fraction, so let me use my ridiculous little pointer here. So with the square root, you graph the inside and you find the roots. When there's a fraction, you graph the top only the top. Find the roots, the zeros, and make sure these numbers do not make the bottom 0. And you see that I checked that. Now, back when I first started introducing graphs, I talked about something called the high point and the low point, which are called maximum and minimum. So I gave you 2 examples of that, which I drew. There's a subtlety here. You see, look, this is a high point, right? You go up, 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 you hit that point, and then you come down, 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 just like a roller coaster. And then you hit the bottom, and then you come back up. Now, this one, you go up, 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 you hit this point, you come back down. The graph never, ever goes back up above this point. Now, the maximum and minimum are Y values. This Y value here is the king of the hill. The graph will never, ever be above that. But here, this is a high point in its area. But when you look at the rest of the graph, look, the graph keeps going up, 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 up. The Y values will eventually surpass this Y value. This Y value might be like, close to 7. But the graph gets bigger than that here. The Y values go to infinity. So this is not the absolute maximum Y value that you'll ever get. It is a maximum relative to the rest of the picture. Sometimes they call it a local max or min, because in its area, it's the high point. But in relation to the whole graph, it is not. Okay, so that's the difference between absolute max and min and relative max and min. I'm recording here. So in the class notes I just showed you, whoops, clear. Go back to y equals. In the class notes I just showed you, I had 2 different functions that had maxes and mins, and they were both polynomials. One was a parabola, one was the x to the third. That's, you can think of it kind of like the roller coaster, where it goes up and down and then back up. So it had a high point and a low point. And those were called relative max and min. So I'm going to graph an x to the third one. So I'm going to put x to the third. So this isn't one that I wrote in the notes. I'm just putting a different one here. So 9x squared, and I'll leave it there a second for you to copy it. Come on, squared. So I have x to the third plus 9x squared. Then I'm going to do plus 15x This is just the one I have in my notes, so I'm hoping it's a good one. Minus 9. All right, so I have x to the third plus 9x squared plus 15x minus 9. I'm going to hit enter. And again, I just want to show you how simple it is to graph this. All right, so x third plus 9x squared plus 15x, take away 9. Now I'm going to hit graph, and I'm going to see what it looks like. Oh boy. Okay. Now, the graph went up, and then it came back down, and then it came back up. So, right, the degree is 3, right? This is x to the third. So the degree, which is the highest power of x, is 3. So it's odd. So that means that the ends do different things. The left end and the right end are doing opposite things. So then I know that this will be what the graph looks like. I just need to see what the high point and the low point are. So I have no choice but to mess with my window. So I'm going to go down, and I'm not going to so I'm going to change my scale. Okay. Now I'm going to try again and see how it looks. Ooh, yay, I got him. Cool. So I changed. Now, again, the window is there. I deliberately have the window here so you can see. All I did was change Y max. Y max is up here. And Y min. Y min is down here. I changed them. I am looking for the low point and the high point. And as always, the calculator does it for you. So I'm going to hit second, calculate. Now look what's underneath 0. Minimum, maximum. Let's do the high point first. Why? Because it came first. And now, oh man, once again, just like with the friggin' zeros, left bound. So you're going to go to the top of the hill, and you're going to go to the left of the top of the hill. So somewhere around there. Hit enter. That's your left bound. Now you're going to go to the right of the top of the hill. So past the top of the hill and go over to the right. And now click enter again. And then again, it asks you, we're thinking about guess. Now I should be at the top of the hill. Woo, yay. Now, here's the hard part. The question is the maximum -5 or is the maximum 16? And what I said to you was that the maximum and minimum are y values. So the maximum occurs when you plug in x equals -5. So you get your maximum y value in this area of the graph when you plug in y is 16. So the maximum is actually 16. So the max is y equals 16. All right, it's not -5. You could write the whole point down, but if I just ask you for the maximum value, you have to tell me 16. Okay, you would not tell me -5. Now I'm going to calculate the low point, which is the minimum. So again, I'm going to hit second, calculate. This time I'm going to go down to minimum and hit enter. And then it's left bound. So working your way to the bottom of the hill or the valley, whatever. Work your way down. Come on, get closer, closer, closer. You don't have to get that close. So remember, you need to be to the left of the bottom of the valley there. So hit enter. Now you're going to move the right bound to the bottom, past the bottom, past, here we go. And then you're going to hit enter, enter. And it should move me to the bottom. Aha. Oh, -16, symmetry. Cool. Now, see again, look, -0.0000001, whatever. This is as good as the calculator could do. My minimum. Now, remember, this is not an absolute minimum. This is a relative or local minimum. It's right there. -16 is the smallest y value that I get in this area. Now, obviously, the graph gets smaller than that over here. That's why this is not called an absolute minimum. The graph does get smaller y values, you know, in a different part of the graph, but relative to the whole picture. That's why they call it a relative or local min. This is the minimum in its area. There's no other y value that's smaller in that part of the graph. So that's, you know, that's the whole point. You have peaks and valleys. So my maximum was 16 and my minimum was -16. Okay, so again, you tell me the numbers for y when you're telling me max and min. So this is how you find them. You hit second, calculate, and then you hit maximum and minimum. and you do the right and left bounds just like you did before.